In this practical, we are going to see how to do spatial filtering. So first of all, let's open our image, go to a directory, and then exercise tree. In exercise tree data, open mynet area 072800 image. And then go to the multispectral and change the band arrangement as 5, 4, 1, like this. Then actually in spatial filtering we can do two types of filtering techniques. One is for temporary Tn value changes and the other one is for the permanent value changes. So in here we are going to see both of this. In the beginning, let's see how temporarily change these pixel values or the Dn values to get and identify the different features on the surface. So here I'm going to remember that you can go through this tutorial as well to find out these details. And first of all, go to raster multispectral, and here you will be able to see an option which is known as filtering. So get that filtering, and in the filtering you will be able to see the same types of standard filters that we have go through with this stretching. So first of all, let's take the smooth filter and see. So you will be able to see that now your image is getting just blurry. So therefore actually this filter is useful to find out the details about mainly the land use types. So you can try this and you have to mention what are the importance of these different filters. And then let's take another filter. Let's move into the sharpen filter, and in sharpen filter you will be able to see that the most of the icons are now very sharp. So therefore we can easily identify the boundaries as well as the different changes and the lines and all these things with this sharpen filter. Then let's take another filter. Let's move into the fine edge filter, and in this filter again you will be able to see, by using this filter we can easily find out the edges of the different land use, mainly like the banks of the rivers, then the roads, as well as the different type of land use and their boundaries. And here it is really clear to see the water body boundary, right? So likewise this filter is helping us to understand these things. And let's take another filter, horizontal filter. So in horizontal filter you will be able to see mostly the lines that are in vertical shape like this. And there is another filter which is known as vertical filter. So here it will provide you some of horizontal shape things in the satellite image. So therefore check these filters and list out what are the different features you can identify by using these different types of filters. and here again by going to the multi-spectral. So to check that, first of all take raster multi-spectral and then stay with the fine edge filter, then change this bands into one band. So I'm putting all to the band 5 like this, and check what are the different areas, so items you can find by only using the band 5, and then change the band into another one. Let's say I'm changing the band arrangement into band 4, and again check the different areas that you can find from the band 4. So likewise you have to change this band arrangement and see the different things that you can find by using these each filters, and you have to list out them. And here within your practical the questions are mentioned, so you need to identify by the appearance and what are the applications of these each filters. So again I'm changing the band arrangement into the previous one, 5, 4 and 1. Then I'm going to show you another thing. So in the filtering we can see another thing which is known as convolution filtering. So go to this convolution filtering, and in convolution filtering you will be able to see the different types of filters in there. Filters like low pass filter, high pass filter, edge enhance, vertical filter, likewise different filters. So your next exercise is you have to go to first of all to the low pass filter and click on low pass filter, then go to edit and see the kernel in there. So this is a tree by tree kernel, or the low pass tree by tree kernel. Then you have to go to your exercise with the practical PDF, and you need to fill these kernels by seeing these different filters. So here you will be able to see mainly 3 types of filters: tree by tree filter, as well as 5 by 5 filter. So this is the low pass 5 by 5 filter, right? And let's see the low pass 7 by 7 filter. So in low pass filter they are just like the smooth shape, so that's the reason why all these values are multiplied with these kernels in one, right? So if we move into another filter, let's say the high pass filter, tree by tree, and you will be able to see the difference between the low pass filter and the high pass filter with the kernel values as well as with the image. So I'm going to open high pass 7 by 7 filter. So there is a larger difference rather than the low pass filter. So you have to go through with each these filters and try to figure out the difference between kernels and how these calculations are done by using these different filters. So during the calculations the kernel is important. So in tree by tree filter the area will only cover 9 pixels, and in 5 by 5 filter the area will cover 25 pixels at once. Then in 7 by 7 filter, the area will cover 49 pixels at once. So therefore there are other filters as well, 9 by 9, 11 by 11 likewise. So then go through with them, and you have to work on these practicals as well. And then I'm going to show you how to create our own filter by using these filters. To do that, first of all, you have to create your own kernel library. So in here, first of all, let's create a high pass filter by using these values in there. And first what I'm going to do is I'm going to this and I'm selecting high pass 3 by 3 filter. Then I'm going to new, first of all select 3 by 3 high pass filter and go to new, and then you will be able to see an empty kernel like this. Then we have to fill this kernel with our values. So here you will be able to see these given values: 1, -2, 1, -2, 5, -2, 1, -2 and 1. So I'm going to complete this kernel with these values. So after completing these values according to this order, then I have to go to the file and librarian, file, librarian. So it will open this kernel librarian window. Or otherwise you can just click on this symbol and you can go to the librarian kernel window. Then now we are going to create a library for us, kernel library. So therefore click on here, this folder icon, and then go to your folder and create a kernel library known as library 1. Click on OK. Then you have created the library, and here rename your filter as 3 by 3 high pass custom. Then click on OK. Now we have saved our 3 by 3 high pass custom filter, and then it will appear here. You can close this now, and here you will be able to see that. So our new high pass filter has came into here like this, and close all other windows in here. Then click on this 3x3 high pass custom filter, or otherwise I will show you it again. So after saving this one, just close this one as well. Then again go to the raster multispectral filtering, and under the filtering go to convolution filtering, and in here you have to select your kernel library or the saved one. To find that, I'm going to click on this folder, and then I'm going to my folder again where I saved my kernel library. So this is my library 1, and here I'm clicking OK. Then now you can see our 3x3 high pass custom fit, and then click on apply. Then close this window, and here by zooming your image, try to figure out what type of changes has happened to the filtering and what features are highlighted by the new filter that we have created. However, the above mentioned filtering techniques that we have used are creating temporal change to the image, so they are not permanent. So to see how apply these filters permanently to the image, now we are going to see how we can do that. And first of all, you need to go to the raster menu, go to the spatial, then on the spatial go to this one, convolution, and in here you will be able to see that it is again providing a view with the same as different types of kernels and the kernel libraries. So here you can apply the permanent filters to your image. So first of all, what you need to do is you have to input your image file. So I'm going to input my image file. So this one, my net area, and then you have to rename the output file as, first move to your exercise folder, and then rename the output file as high pass image. Then click on OK, and here under the kernel selection, go to the kernel library by clicking on this folder, and then find your kernel that you have already created in the kernel library. So this one, library 1, and click OK. Then you will be able to see the different types of kernels that you have already prepared, and I'm going to select 3x3 high pass custom, click on that, and then click OK. And in this process we can create permanently filtered image by using Erdas Imagine. Then open your high pass filtered image, so this one, and see what are the different type of features that you can understand by looking at this layer. And you can go to the raster and multi-spectra, and you can change the band combination as well to see these changes and check, is it better to clarify the different areas with the land use. And now let's check the other filters that you can use. So in here, now I'm going to look at the edge filter. Right. So therefore, to make a edge filter, first clear your view and then go to the raster, spatial, under spatial go to convolution. Then in this kernel selection, under the kernel, select tree by tree edge detect and click on new. Then use these kernel values to fill your kernel for create this north directional edge filter. So I'm putting these values. One in here and here -2. 1 -1 -1. Then go to the file and library, or you can just click on this icon, then open your data folder and here click on your library one and then rename this new one as north direction like this, and then click save. Then here you will be able to see that now your new filter is added to here, and if you need to remove the other filters in this list, what you can do is you can click on the filter that you don't need and then click on delete. Yes, right. So then we have saved our new filter, which is known as no direction filter. I'm going to close this one and let's apply our new filter. Close all this and again go to the raster menu and spatial, go to convolution, then give your input image as our image, the same one, and then go to output file and go to your folder, save this image as north. And then in here select your library one again, and on the library one select the north direction filter, then click OK and run the process. After the process ran, close this window and open your newly filtered image, which is known as north image, and then check the features that you can understand by using this north image. And here you will be able to see that by preparing that image you will be able to filter the different features, and go to this image and try to figure out what are the different things that you can identify by using this image. And then let's check another filter. So I'm going to remove this one. So the next filter is non-directional filter, which is known as Laplacian filter. So now I'm going to apply this Laplacian filter. So first of all, we have to create a new filter. So therefore, go to the raster, spatial, and then convolution. And under convolution, select Laplacian 3x3, this one, and then click on new, and let's input these values to this 3x3 kernel. Like this. And then after entering these values into your filter, this has to be +8. Then again go to the librarian and select your default library, and rename this filter as Laplacian. Then click save. Now here the new filter has added to your library. Then close this one, and in the convolution, give the input file as -area1, then give the output file as Laplacian. Then click on OK. And under the kernel selection, so here your kernel library have already added, and under the kernel select Laplacian, then click OK. And after the process, let's see how this Laplacian filter has filtered our image. So close this one, and let's open our Laplacian image. So here you'll be able to see how the Laplacian is worked to highlight the different features in the image. And in here, change the band into one band, select layer 1, then try to figure out what are the different features that you can identify from the image, and again select only band 4 in there, and again try to see the features that you can identify by using this Laplacian filter. finally, let's see another type of filter that we can use in Erdas Imagine. To open that one, go to raster, and under the raster menu, go to spatial, and here you will be able to see non-directional edge. So in non-directional edge, we are going to do how the Sobel filter is working. So first of all, within this window, give the input file as our data file. So the minute area 072 image. Then give the output file as Sobel. Like this. Then click on OK. And then here you will be able to see the output options. In here the filter selection has to be Sobel. Then you can run the process by clicking OK. So in here, remember that this Sobel filter is working with two kernels, and by using two convolutions they have made this output image, which is known as Sobel filter. So we can see the process of this Sobel filter by looking at the Sobel filter model as well. Let's see that one. So before that, let's open our Sobel image in the viewer. So I'm going to open that image. So this is the Sobel image. So in here, you'll be able to see that now you can identify the other different areas as well with the different types of land use patterns, the land use types, right? So think, so which one is the best to identify the different land use features in our satellite image. So then I will show you how to see the process of the Sobel filter. So I'm going to raster again, and under the spatial, non-directional edge, and in here I'm clicking on view. So by clicking on view, we can see the model of this filter. So it is something like this. We have the input raster in here, and the two Sobels are running, and the convolution two functions gives two outputs. Then finally it creates, by using the two outputs in one output raster image, which is known as Sobel, right? So if you need to see the kernels of this Sobel function, what you can do is you can just double click on this matrix, and you will be able to see these kernels and with their coefficients, and also this one as well.